Hi guys, so this video is going to teach you how to learn about aldehydes and ketones. So we're going to start with aldehydes, but we're going to write ketones over here as well, because aldehydes and ketones are actually extremely similar to each other. So both aldehydes and ketones have this special group called a carbonyl group. So they both have a carbonyl. Okay, so a carbonyl group is a carbon that has a double bonded oxygen. So they both have a carbon with a double bonded oxygen. And the difference between aldehydes and ketones is in aldehydes, the carbonyl is at the end of a chain. And with a ketone, it's somewhere in the middle, meaning not at the end. So an example of an aldehyde, we've got a carbonyl here, and we've got a 3-carbon chain here. So that one's an aldehyde. And then we've got a carbonyl here, but it's not at the end, it's somewhere in the middle. And so that one's a ketone. Okay, and so the difference is, again, that in the aldehyde, the carbonyl, that double bonded oxygen to a carbon, is at the end of the chain. Doesn't matter which end it is, both ends are the same, but it has to be at the end of a chain. Whereas in the carbonyl group, it is not at the end. It's somewhere on one of the middle carbons. Okay, so the name for this aldehyde is going to be prop, because it's got 3 carbons, and it's going to end in al. Aldehydes end in al. You have to be careful because your A's can sometimes start to look like O's, meaning that they look like alcohols, but they are not alcohols because they have a double bonded oxygen, not an OH, and so they have to end in AL. So you have to be really careful about making sure that you form your A very properly so that it doesn't accidentally look like an O. All right, with our ketones, so this ketone has 5 carbons in it, so it's going to be a pent. And then the ketone, that double bonded oxygen, is on the 2nd carbon in, and ketones are going to end in -one. So this one is going to be penta-2-one. Okay, so our aldehydes end in al, ketones end in -one. Okay, with an aldehyde, you will never require a number to show where the carbonyl is. The definition of an aldehyde is that the carbonyl is at the end of the chain. With a ketone, number is required, okay? With the only exceptions being if there's only one way to put your double bonded oxygen in the middle, then we don't need a number, because we never need numbers to show locations of objects or things in our molecules that only have one location. So they only have one location, they don't need a number. So for example, if you have a ketone that only has 3 carbons and it's a ketone, this is going to be propanone. Okay, it's going to end in -one because it's got that double bonded oxygen in the middle of the chain, not at the end, so it's not an aldehyde, it's a ketone. But we don't need a number because there's only one place for that double bonded oxygen to go in the middle of the chain. There is only one spot for it to be located. Okay. Now, when you're numbering our ketones, we always want to start from the side that's going to give us the lowest number for our double bonded oxygen. So we number to get lowest number for the ketone group. Okay, so if we say have a ketone, it looks like this. We've got a double bonded oxygen here, and so we have a methyl branch over here. Then we're going to number this with 1, 2, 3, 4, 5. Rather than numbering from the right side, we're going to number from the left so that our ketone has the lowest number. So this one is going to be 4-methyl We're going to name our branches just like we normally name branches. And this would be a penta, 2-one. So then our double bonded oxygen is on carbon number 2. Okay. So branches get numbered just like they normally would. We're going to name our branches right at the beginning of our name. But we're numbering now for the ketone. So the ketone is deciding on where we start numbering from. When we're looking at those aldehydes, we're never going to need a number to show where the aldehyde is, but the carbon with a double bonded oxygen is carbon number 1 always. So if we have branches on our aldehyde, so let's just draw a new aldehyde here. And say we've got a branch there on our aldehyde. So this is going to be 1, 2, 3, 4. So when we number our aldehydes, we're going to number from the side that has the aldehyde, that has the double bonded oxygen. Okay, so we're going to be, this is going to be 3-methyl butanal. It's going to end in al because it's an aldehyde. That double bonded oxygen is at the end of the chain. Okay. One of the other things with our ketones and our aldehydes is we can have 2 double bonded oxygen groups or 2 ketone groups, 2 aldehyde groups. And we're just going to use what we've been using with our double bonds or our triple bonds. And we're going to use a di or a tri to show that we have 2 or 3. So say we have 2 ketone groups. So looking at this molecule. So this molecule is a pent, okay? And so it's going to start with pent. And then on the second carbon and the third carbon is where we have our ketone groups. And there are 2 of them. So we get di-one to say there are 2 of those double bonded oxygens. And the 2 and the 3 tell us where they're located. And again, we're going to start numbering so that they get the lowest numbers we can. So we started numbering from the left of this molecule rather than from the right. Okay. There are a couple of special, there's one special aldehyde, and it's when benzene has an aldehyde on it. So when we have this benzene ring, so we know what benzene looks like. And then when we add a carbon that has a double bonded oxygen, we can't put the double bonded oxygen directly on one of the carbons in the benzene ring because each of the carbons in the benzene ring already has 3 bonds to carbon. And so we need to add an extra carbon to make a double bonded oxygen happen as well. And so this molecule is actually called benzaldehyde. It's just got a special name. Unfortunately, with the benzenes, they are things that you often just need to memorize the name of when they have a special group attached to them. So just like we looked at when benzene had an alcohol group, it was called phenol. When benzene has a double bonded oxygen group, it's called benzaldehyde. There is no such thing as like a benz ketone because on the benzene ring, when we add that carbon with a double bonded oxygen, that's automatically at the end of that chain. And so it's going to be an aldehyde, not a ketone. All right, so that's it for aldehydes and ketones, okay? And that's the end of what's going to be on quiz number 1. And so you can now do all of the practice in your duotang for aldehydes and for ketones. Please make sure that you look at the website because the website also has answer keys for all of the molecules that are in your practice in your duotang.